Okay, you guys, I just recorded about 15 minutes worth of notes, and instead of moving on to the next page, I deleted it. So if it seems like I'm rushing through these, it's because I just did them and I'm annoyed. So let's start with 5.3. Multiplying algebraic fractions will look just like it looked when we multiply regular fractions. Let me give you a couple of examples. So if I take 1/5 and multiply it by 2/3. I do not need a common denominator to multiply these two fractions. I simply take my my numerators, 1 times 2, and multiply my denominator, 5 times 3. Okay, I'm going to show one more quick example, and then we'll actually do the other problems. In the cases where you've got something like this, 2/3 times 6, times, times 6 over 14. In something like this, you have a couple of options. You can start by immediately multiplying the numerators together to get 12, multiply the denominators together to get 42, and then you can simplify because 12 over 42 certainly has common factors, or you can make some cancellations before you even start. You might see the 3 and the 6 and recognize that that will simplify to 2 over 1 because basically these are a part of the same fraction. Now we're just multiplying. And you can make those cancellations ahead of time. And then I can see that this 2 will cancel into a 1 as the 14 will change to a 7 when I cancel out that 2. So in the end, we'll end up at the same spot. This equals 2 over 7, which is how 12 over 42 simplifies. If you factor out a 6 from both of those. So you can factor and cancel out common factors at the very end. You can cancel out common factors as you notice them throughout the problem. There's a little bit of wiggle room for how you want to approach it. So when we're looking at all of these problems, as you can tell, these are mostly quadratic expressions. And they will mostly, all of them will be able to factor. And that is always the very first thing you're going to want to do with these problems. Before we follow our process for multiplying fractions by multiplying the numerator and denominator, think about what would happen if you jumped right in and started multiplying these by distributing how many terms you would have in that process and combining like terms and then factoring in the end. So before we even do the multiplication, you are always going to want to factor first. That will make it easier for you. Factor first. So in this first problem of example 1, I'm going to start on the very first quadratic. So again, some of you need a little more practice with factoring. Some of you are feeling good about it. It's not something you want to breeze over and ignore because you just can't ignore it anymore. So x squared plus 6 or minus 6x plus 9, I'm looking for two numbers that multiply to positive 9 and add to negative 6. That's going to be x minus 3 times itself, x minus 3. So that's actually a perfect square. The denominator you should recognize as a difference of squares. So that has a formula too for how we handle it. That will be x plus 1 times x minus 1. Okay, the second fraction, the numerator, all we can do is factor 2 out. And the denominator is just x minus 3. So you should begin to see these common factors that we can simplify now. So when we do the multiplication, we will just multiply all of this together in the numerator, all of this together in the denominator, but we might as well cancel out some common factors between numerator and denominator to make it a simpler process. So we see x minus 3 here and here. We also see x minus 1 here and here. So when we go ahead and multiply, our new product will be 2 times x minus 3 divided by x plus 1. So that's our final product once we cancel out all of those common factors. We do want to make sure that we finish the problem as we were instructed to and state any domain restrictions. So we have the clear domain restriction that we get with the denominator of x plus 1 in our final product. But we also need to include any domain restrictions. So that means x cannot equal -1. Any restrictions that would have occurred prior to our final step. Meaning these cancellations I made are still restrictions because those are a part of our original problem. Even though we canceled them out, those are still restrictions in our original two rational expressions. So that means we would add the restriction of +1 and -3. So these are our restrictions. Okay, moving on to example 2. Here we have 4 quadratics. That's a lot of factoring. In fact, I would encourage you to just pause the video, factor them yourselves. Oftentimes, I know you guys kind of just wait for me to do the factoring, but when you're skipping the process happening in your own brain, you're just not getting the process. So I would encourage you to just pause, factor, and then restart the video, fast forward a little bit, and just make sure you're factoring correctly, especially with these two denominators. You see the same values, 5x and 6, 5x and 6, but with opposite signs. These will factor very differently from each other, and I see a lot of common errors with quadratics like that, with people just mixing up 2's, 3's, and 1's and 6's with that type of quadratic. So let's go ahead and start factoring on the top left of the first expression. So I need two numbers that multiply to 9 and add to 10. That's going to be 9 and 1. So x plus 9, x plus 1. I'm going to stick with that first expression and move to the bottom. I need two numbers that multiply to 6 and add to 5. So that's going to be 2 and 3. I'm going to move on to my second one now. So x squared minus 5x minus 14. I need two numbers that multiply to -14 but add to -5. That would be -7 and +2. And then the denominator, two numbers that multiply to -6 and add to -5. It is not simply the negative of how we factored this one. Those two numbers, to multiply to -6 and get to -5, that would be x minus 6 and then x plus 1. Okay, so once I've done that, stop and take a look back, and what cancellations can we make? What are the common factors? So we've got x plus 1 and x plus 1, x plus 2, and x plus 2. So that will be all of the canceling we can do. And then we can write our final product. The factors remaining are x plus 9 times x minus 7 over x plus 3 times x minus 6. So that is the product. You do not need to distribute these back through and write them in terms of the way it was originally presented up here. You can just leave it in factored form. We do not want to forget about the restrictions though. So we have the obvious restrictions from our product, our final product at the end. X can't be -3 or +6. But we also need to go back and look at those two that we canceled out, meaning -1 and -2 are also restrictions on x because they are restrictions on our original problem. Okay, so let's move on to division of rational expressions. Usually we don't like dividing things. We shy away from it because dividing means fractions. However, if we're dividing fractions, it actually is a little bit easier than we think it's going to be, because if you remember how we divide regular fractions, meaning with integers, for example, 1/4 divided by 5/6, we can rewrite that division as a multiplication problem, and we already know how to multiply fractions. So we can rewrite this as 1/4 times the reciprocal, 6/5. At that point, you can multiply numerator and denominator, or you can make any cancellations you want with a 4 and 6. It doesn't matter which order. So we get 6/20, both of which are divisible by 2. So with these division problems, it's almost exactly the same process as multiplication, but you just have that added step of switching the sign and flipping that second fraction. Otherwise, you're still going to factor, you're still going to cancel out common terms between numerator and denominator, but be careful because you're not going to cancel out those common terms until you rewrite that second fraction using its reciprocal. So don't make any cancellations until the very end after you have flipped that second fraction. So let's do problem 3. Okay, so in problem 3, my first numerator there, 4u squared minus 16. The first thing I noticed there is that 4 is a factor of both 4 and 16. So I'm going to just start by factoring out a 4. That leaves me with u squared minus 4. And as you write it, hopefully you'll stop and recognize, wait a minute, that's a difference of squares. I can factor that again, which is great, but I'm just going to do that in a minute after I continue factoring the denominator. We do not need to do everything in one step here, so make sure you're not rushing through too many steps all at the same time. My denominator of that first fraction also has a common factor of 4, so I'm going to factor that 4 out of the denominator, which will result in u squared minus 2u minus 16. And then I'm actually going to go ahead and rewrite this as a multiplication problem right now. So I usually do it pretty early on, just so I make sure I've not forgotten that step. So I'm going to change this to multiplication at the same time I rewrite my second fraction as the reciprocal, u minus 2. Okay, now moving forward, I still have some factoring to do in my first fraction. U squared minus 4 is a difference of squares. So I can rewrite that as u plus 2 times u minus 2. In the denominator, I have 4 times, some of you may have already canceled out those 4s, that's totally fine. So u squared minus 2u minus 16. Two numbers that multiply to negative 16. And, no, not 16. My bad. That should be 32 divided by 4, which is 8. Two numbers that multiply to negative 8 and add to negative 2. So that would be u plus 2 times u minus 4. Yes, okay. And then the second fraction is just 4 minus u over u minus 2. And there is something I'm going to say about that in a second. I'm just going to leave it like that for now. Okay, so now we have everything factored. We had the common factor of 4 in the numerator and denominator, so that's gone. We have u plus 2 here, u plus 2 there, u minus 2 here, u minus 2 there. So all we're left with, we see, is 4 minus u over u minus 4. And that should catch your attention because you want so badly to cancel it out because it's just so similar, but it's not the exact same thing. In fact, they are exact opposites of each other. So we can do something with this, but we need to rewrite it a little bit. So 4 minus u, the 4 is the opposite sign that we want it to be, and so is the u. We want this to be a negative 4 plus u. Then we could rewrite it, and it would be the exact same thing down in the denominator. We can do that. All we have to do is just factor out a negative 1 from that numerator or denominator. So if I factor a negative 1 out of both of these terms, what that's going to do is make my 4 negative and the u positive. So it's actually going to be negative 1 times u minus 4 over u minus 4. So if you ever see that where it's the exact what you want it to be, but the signs are flip-flopped, factor out a negative 1. So this entire expression with the division in the very end, this whole thing simplifies to negative 1. But we have lots of restrictions to think about, so we're not quite done. We have all the restrictions from the original problem to consider. So with division, there's always some restrictions that we don't want to forget, and that would be the restrictions from the original problem here from 4 minus u, which means u cannot equal 4. And then we flipped that to get the reciprocal, and we have the restriction from that denominator as well, which means it can't be 2. So we actually take the restriction from the entire, both numerator and denominator of the second fraction, because we use them both ways. They're both restrictions. And then we have those restrictions from our denominator of the first fraction, which would be negative 2 and 4. And the 4 is already represented there. So the whole darn thing simplifies to negative 1, and we have our restrictions as well. All right, so as you can see, we basically just did 3 very similar problems. You first begin by factoring. You're going to cancel out common factors. If you're dividing, you have that extra step of multiplying by the reciprocal. Otherwise, you're factoring, canceling, simplifying, and writing restrictions. So if you're feeling confident at this point, you've seen the bulk of examples 1 through 4, and you should go ahead and move on to example 5. If you feel like you just need to practice a little bit more, especially with the division, hang with me here through example 4 and just make sure you're on the right track, or even just pause it, do example 4 on your own, and then fast forward to the end of my example 4 and just double check that you're on the right track. This would be a good time to do that. So I'm going to go ahead and work through example 4, and beginning with factoring out my first fraction. So I can just factor out a 2 of the numerator. My denominator is x plus 6. I'm going to go ahead, just like I did on the last one, I'm going to switch to multiplication right now. And my numerator is now going to be x squared plus 4x minus 12. I'm going to factor that right now. So that would be what multiplies to negative 12 and adds to positive 4. That would be x minus 6 times, x plus 6 times x minus 2 divided by, divided by 3x plus 8, which is just 3x plus 8. So now we factored everything. This was kind of a nice, simple factoring problem. Now we can go ahead and make any cancellation. So I've got x plus 6 and x plus 6. Beyond that, there's nothing else I can cancel. So you might see this x minus 2 and x minus 2 and want to cancel that, especially if you didn't change this to the reciprocal in the very first step. But we cannot cancel those out if they are not opposing each other in the numerator and denominator in this multiplication step. So this is all we can do. So now we can finally write our product. So that's going to be 2 times x minus 2 squared, because we have this one and this one, all over 3x plus 8. So this is our product, and now I will write my restrictions. So x cannot be negative 8/3. That comes from the denominator of my final product. It also cannot be negative 6, so I can't forget about that restriction from a previous step in the problem. So you've seen how to multiply and divide rational expressions. So let's move on to example 5 and 6. This is rationalizing the denominator. We did this last class. I'm just going to skip these. So we did these before. If you want to practice it, by all means, pause the video and practice. The completed notes of this section are also on Schoology, but to review the steps, you need to multiply top and bottom by the conjugate of 4 plus root 3, which would be 4 minus root 3. In doing so, you will end up canceling out the roots in the denominator, which will rationalize the denominator. But this section is, so that the reason these problems are in here is because in order to rationalize a denominator, you're multiplying algebraic rational expressions, like we have been in the first few examples. So we're just going to move on to the next page. Okay, page 2, complex fractions, everyone's favorite. A complex fraction is a fraction that has a fraction in the numerator or denominator, or if you're really lucky, in both. So it's a fraction with, it's hard to write on this, so I apologize. With a fraction in the numerator or the denominator or both, which is the best. Okay, so to simplify complex fractions, remember we talked about this. There are two methods to do this. The first method would be to rewrite the numerator and denominator as one single fraction and then just multiply by the reciprocal, just like we saw on page 1. So in this case, it would be 2/3 times 5/4, which would be 10/12. So we see that would be what is considered to be method 1. Just multiply by the reciprocal once you have simplified it to one fraction divided by another fraction. And then this simplifies to 5/6. So the second method would be what we saw last class, where you multiply the numerator and denominator both by the common denominator between the two fractions. So my two denominators are 3 and 5, which means my common denominator would be 15. So if I multiply both of these by 15. The reason it doesn't make as much sense in a problem like this, but in algebraic expressions it does. So when I multiply 15 by 2 divided by 3, the 15 and the 3, that's just 15 divided by 3, that's just 5. So this ends up simplifying to 2 times 5. And then in the denominator, the 15 divided by 5, when we do 15 times 4 divided by 5, that just simplifies to 3, so that's just 4 times 3. So it gets us to the same result in the end, 10/12. And I do not care which one you choose. I really do think this second method is a lot cleaner and faster in many cases, kind of like in problem 8. So I'll do problem 8 in both ways. So in problem 8, we've got this complex fraction because we have a fraction within a fraction, both in the numerator and denominator. So with this, don't forget what I wrote on the top of the notes. Factor first. If you can factor, do it. So I'm going to rewrite this. I can factor a 3 out here, and I end up with 7 minus 2x divided by y. Now I'm going to multiply by the reciprocal of that second fraction. So y squared minus 3y. I'm going to factor that y out in this step. Divided by 2x minus 7. Cool. So what do we have? We have a y that we can cancel, 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 and then you should see this. It's 7 minus 2x and 2x minus 7. It's flip-flopped. We want the one to look like the other, but their signs are reversed. So don't forget, I can factor a -1 out of either of these, and then I will have what I want it to be. So when I factor a -1 out of this, it changes the -2x to or positive 2x to negative, and the -7 to a positive, which means now I can go ahead and cancel those. But what I can't forget is that I have a -1 here multiplied by that whole thing. So those can cancel now, and this results in 3 times y minus 3 divided by -1. Which means I can just rewrite this as -3 times y minus 3. You can leave it like that. You can multiply the 3 through. I'm fine with either. We can't forget our restrictions, though. Even though our final quotient, I guess, since this was a division problem, Our final quotient does not have a denominator. There are no apparent restrictions when you just look at it, but there were restrictions from our original. We have this restriction because y is in the denominator. This means y cannot equal 0. We also have this restriction. Even though I changed it to multiplication and switched it, I still have a restriction there, which means y can't equal 0 and y can't equal positive 3. And then I have this restriction. I had 2x minus 7 in the denominator, which means x cannot equal 7 halves. So we have those 3 restrictions. Okay, so that would be what I considered method 1, just multiplying by the reciprocal. And I'm going to leave it at this. So I wanted this video to be no longer than 20 minutes, so I think I'm right around that mark. I'm going to stop, and at this point I want you to move on to 5.4, which will be adding and subtracting rational expressions.